All right.
Hold on, let me,
Whenever
oops.
you're ready, read away. And
So the first equation we have is x squared plus y squared minus 12x plus 4y equals 41. And then we have to find the center in the radius. And then draw the graph.
so they're telling you it's a circle.
Mm-hmm.
Okay. What's the general equation of a circle? It's always where you have to start with these.
It's, I remember what you said, isn't it like y equals x squared or something like that?
No, it's the equation of a
No.
parabola.
It's the equation of a parabola.
Right now, we need the
I know.
equation of a circle.
I remember it's something. I remember it too. It's just super dumb. I just can't remember, of course. It's.
Oops, hold on. That's a Y. That's what it is.
Oh, okay. So it's
H?
h minus k squared.
Well, no. Yeah.
Okay.
H and K are the center, and R is the radius. And
H and k. Okay.
that's the three things they asked for here. Was the center and the radius. So if we can take this equation and put it into that format, we'll have our answers.
So do we need to find the square root of 41 first?
No,
No.
we got to put
Okay.
the
Well.
entire equation into this format. Conic sections, virtually every problem you have to complete the square. So know
Okay.
that you're going to have to complete the square to do this.
Alrighty. Do we have to simplify the first equation now? We have to like separate the y's and the
We
x's.
have to rearrange the first equation. In
Okay.
order to complete the square, I have to have the x terms together and I have to have the y terms together. So
Okay.
I'm going to start
So.
off by doing this. I'm going to put the x terms together. I'm going to put a parentheses around it, and I'm going to leave room to complete the square. And I'm going to do the same thing for the y terms.
Okay.
And that's equal to 41. So the key thing when you're doing these problems with conic sections is to go from one step to the other without changing the original equation. Notice that I've got exactly what I started with. I haven't changed anything. I've just rearranged it. It's all about rearranging it.
Okay.
Okay. Now let's complete the square. What do I have to do inside the x parentheses to complete the square?
We take half of negative 12 and square it.
Okay. What do you get? What
So
is
that's 6. 36.
Okay, and it's always being added. Whenever you're completing the square, it's always added. So what do I have to do to the right side? Because I just changed the left side.
Same thing. So it'd just be 4.
I got to add
Right?
36.
Yeah, that's
So
I know
what I
what
just did was added 36 to the left side and added 36 to the right side. So I still haven't changed
Okay.
the original formula, the original equation. Now do the same thing in the y's.
Okay, so we take half, which is 2 squared, 4. And we add 4.
Okay. Now, because we completed the square, I am always going to be able to write this in this way. That's why we completed the square, is so that I could write it as a binomial term squared. So what is that?
Okay, so we'd have x minus 6 squared
Perfect.
plus y minus 4 squared.
It's always
There's
the
a 2.
sign of that middle term. So in the y case, it's y plus 2 squared.
Okay,
Not
equals
4,
81.
it's whatever you got when you took half of it. That's the
Okay, and then it's
term. Okay, and then the other side is 81. Okay, now
okay.
haven't changed it. It's still exactly the same equation. We've just rearranged it. But we've rearranged it into the standard format for a circle, and now we can tell where the center is and what R is. What's H?
Okay. H is -6.
Nope.
No? Is it just 6?
Uh-huh. Notice this
Okay.
X minus H. So when I say what is H, it's only 6.
Okay.
What is K?
2.
Nope.
-2?
Uh-huh.
Okay.
You see why?
Yeah.
If I'm taking y minus a -2, it turns out to end up looking at y plus 2. So when you see a y plus 2, you know that the k is -2.
Okay, that makes sense.
And then what is r?
9.
Yes. And there's your answer.
Okay, how do we graph that? Do we...
Pretty easily. There's fewer things easier to graph than a circle. You find the center. There's
Okay.
6 comma minus 2. And you draw a circle around it of radius 9. Well, radius 9 puts one side about like that. Not much of a artist, but you get the idea.
Yeah.
In other words, this radius is 9. All right.
I think that was weird.
What's that?
I heard some, like, crashing in my house. I'll be right back.
Okay.
The wind just blew some stuff over on my deck.
Oh, yeah. It's windy out where I live also.
Mm-hmm.
Yeah.
So where does the radius go? So the center is on 6, -2. And then the radius goes on 9.
9, and you draw a circle. The radius is the distance from the center to the edge.
Okay. I'm just trying to figure out where this... Hold on. It's just like weird. Let me see if I can...
Oh, you're trying to do it in the software.
Yeah, it's like really weird.
Well, that I can't help you with because I'm not looking at it. But you probably have to pick a circle icon and start at its center, is my guess.
Okay, yeah, the point I'm at is 6, -2.
Okay.
And then does the radius just go up 9?
Goes any direction 9. That's what a circle is. It's the locus of all points that are r distance away from the circle, the center of the circle. Every point on this circle is exactly 9 away from the center.
Okay.
So if you were drawing it with a protractor, you'd put your middle point there, you'd lengthen it to 9, and you'd circle it. Or a pencil on a string.
Yeah, I figured it out. Okay. I got that right.
Okay.
The next one is... Let me know when you're ready.
Go ahead.
Okay, we have x² plus y² plus 4x minus 2y equals 44.
Okay, you do this one for me. Same
Okay,
thing,
so we have to,
circle, and they're still going to ask about the center and the radius.
okay.
What's the first step?
Hold on. Sorry, there's stuff blowing all over my deck, and I live on the 3rd floor, so it's going to blow off. I'll be right back.
Okay.
All right, so I started driving home today, right?
What's that?
And I said I started driving home today, right?
Yeah.
And I was waiting for this guy to turn, and he was turning, and so I had to go slow to compensate for him like turning, and I rear-end him, right?
Yeah.
And this guy behind me starts like freaking out and speeds past me like 30 over, and then like follows me for like 10 minutes, just yelling at me. And I'm like, oh my gosh, chill out.
Road rage.
Yeah, I guess so.
Yeah, no, you probably should report that.
Yeah.
There's a number you can call to report drivers that are suffering from road rage. And that sounds like a clear example of it.
Yeah, I need to do that because that was kind of ridiculous.
A lot of times, I'll tell you what you have to do. I've found myself in this situation before. What I do is pull out my phone and pretend to be making a call. That usually gets rid of them pretty quick.
Yeah, I bet.
You guaranteed it does. They know exactly what you're doing. You pull out that phone call and you hold it up and you start dialing. They don't want no highway patrol after them because somebody reported them for road rage.
Yeah, it's pretty ridiculous what people do.
All right, so we're going to do exactly the same thing with this as we did with the last one. But you really need to start off with the general formula. Tell me what the general formula is.
We have x plus h squared.
Always minus, always. You have never once
X.
run into an x plus h. You will in calculus, but not in precalculus. It's always x minus h. Now, it doesn't matter whether you're talking about parabolas, circles, ellipses, hyperbolas. It's all x minus h and y minus.
Okay, so it's x minus. Alrighty then. So it's x minus h squared plus y minus k squared equals r squared.
Okay.
And then we just have to plug in for this. And
no, there's no plugging
so
in.
We have to
rearranging.
Well, no. Yeah, we're rearranging.
We're trying to make this look like that. We're going to rearrange it. We're going to complete the square. That's what you need to remember.
So we have. Okay, the first thing we do is x squared plus 4x, and then these are parentheses.
Okay, and leave room to complete the square. In other words, you know you're going to have to complete the square.
Plus y squared.
Keep going.
And then we have to, and then we say equals.
You forget one of these terms. You're forgetting the minus 2y.
Yeah, oh, I said that, didn't I? My bad.
I didn't hear it.
So it's minus, oh no, it's minus 2y, leave space, equals 44.
Okay, so it's all, that's the rearranging part. Now let's do the completing the square part.
All right, so you take half of the first one and square it.
Just tell me what number goes in here.
Okay, just a second. So it should be 4, right?
Okay, and tell me what I have to do now.
Now you add the 4 to the 44.
Uh-huh. Okay, and then how can I write that? Let's go ahead and get this firmly implanted. How's that going to how can I write it now? Remember, I'm trying to write it as a linear term squared. That's what x minus h is a linear term squared. So what
Okay,
does that
so it's
linear term mean?
x minus 2 squared.
Hold on. The sign that goes here is always the sign of the middle term. You see that? In other words, whether it's x plus or x minus depends on the sign of the middle term. If it's plus, then it's plus. If it's minus, like it's going to be on the y, then it's going to be
Sorry,
a y minus.
I was in a call. My bad. I got called by my mom.
Didn't know
But
that. I don't know how much
I
you
thought I
heard what I
said
said.
something.
What I was
I
saying
heard like the
was
last
the
part.
sign between the x and the number is always the same sign as the sign of this middle term right here.
Okay.
Okay? So how am I going to write the, well, first of all, let's complete the square on the y.
Yeah. Okay. So to complete the square, we take the half, which is 1, which is so it's just -1 in this case. Or squared, it's actually +1.
So just tell me, the only thing I need to know is what I should write here.
Which you should write in the space would be +1.
Okay, what do I have to the other side?
Add the 1,
Okay, now
and then
rewrite this as a linear term squared.
we have y minus 1, right? And
And
then squared, and then it
I have
equals
3 numbers on the right side.
49.
And again, this is identical to that,
Mm-hmm.
rearranged. Now
Okay.
tell me the x coordinate of the center.
The x coordinate of the center. So we have it's 2, -1.
Nope.
Mm-hmm. Okay.
Remember, it's always opposite this sign. You're looking
Oh,
at a
so it's
plus 2.
negative.
So it's always
It's
going to be
-2,
minus 2.
1.
And
Okay.
what's the center of the y? Or what's the, excuse me, the y
+1.
coordinate of the center?
+1.
Uh-huh. And finally, what is the radius?
It's 7.
Okay. And then in terms of graphing that, put your thing on the center and draw a circle with radius 7.
Okay.
In other words, the center is at -2, +1, and a radius of 7. It's going to look something like that.
Okay. Um, Let me just check to see if there's some bigger ones here.
Excuse me. My throat's about to give out. I'm glad Thanksgiving week's coming up.
Right.
Oh, I've been bordering on the hoarse voice for all week.
Okay. I hate that feeling.
Yeah, I do too. Especially when you have to keep talking. And I got
Oh yeah,
a
absolutely.
full day the rest of today, so.
Am I scheduled for tomorrow?
Okay, that's fine. I don't have much on Friday.
No.
Oh,
No,
are
I
you
was just wondering.
scheduled for tomorrow? Hold on, let me look. I do. I got you down at 5 o'clock.
Okay.
That still work?
I work. Yeah.
Okay.
Right there.
What else we got?
Um, I'm just checking to see if there's some bigger problems to do. Because
Okay.
like I get
Is
enough. I'm
circles
just
the
trying.
only thing you have covered at this point? I mean, you haven't gotten to ellipses or hyperbolas?
We've been to that, and I'm just trying to find some more of those questions instead of circles.
Well, those are quite a bit harder than circles. So
Yeah.
if you've covered ellipses, let's find an ellipse question.
I have one right here,
Okay. And
and
if
it's
they give it to you as a polynomial, that's fine. Give it to me as a polynomial.
Let me read it to you real
The
quick.
last two problems you did, they gave them to you as polynomials. You had to put it into circle format. And
This is like a
go ahead.
one. It says the bridge support is represented by the top half of an ellipse shown in the figure to the right. The point Q, which is the center of the ellipse, is at the origin. The bridge support is 13 feet high and it centers 24 feet from either end of the bridge to the center.
13 feet high?
Yeah.
And what was the rest of it?
It's 24 feet from either end to the bridge to the center.
So that's 24 and that's 24.
Mm-hmm.
Right? Okay.
And it says find an equation that best describes this flow. Huh?
Do I have an accurate picture?
Yeah, that looks exactly what it is.
Okay. It's the general format of an ellipse. You absolutely have got to memorize the general formats. It's the only way to really do these problems is by starting at the general format.
Is it? I'm trying to remember it.
Well, that's better than looking it up. If you had it on a piece of paper in front of you, I would ask you to turn it over and try to memorize it. Because that's the only way to memorize anything. You don't ever memorize anything by turning to the page in the book and looking it up. You just don't, it doesn't sink in by osmosis. You have to actively try to memorize stuff. And by that, I mean test yourself every single time. Okay, what's the rest?
Is it the h minus, or is it x minus h, or is it like written differently?
It's y minus k. It's a lot like a circle. An ellipse is not that different than a circle. Here's the key difference. There's denominators under the ellipse. Okay?
Oh, okay.
And there are actually two formats for an ellipse. So it's even harder. There's only one format for the equation of a circle. There's two for an ellipse. And the difference between these, you'll notice, is which variable the A or the B are under. This ellipse is an ellipse, horizontal ellipse, like that. This ellipse down here is a vertical ellipse, like that.
Okay, that makes sense.
Here's how you can tell the difference. A is always from the center of the ellipse measured on the major transverse axis, the longest axis. That's always A. In the horizontal ellipse, A goes with X, right? It's on the x-axis. In a vertical ellipse, that distance is A, and that's on the y-axis. So the A squared goes under the y variable in a vertical ellipse. Follow me?
Yeah, I gotcha.
A always is bigger than B for an ellipse. Notice that B is this distance. Well, the longer distance is always going to be greater than the shorter distance, no matter which way it is. In other words, A is greater than B.
Okay.
Okay? Now, let's fill in everything here. Let's fill in everything we know. We kind of know everything. They want, well, what do they want? They want the equation of the support?
Yeah.
Okay.
Which equation that best describes the ellipse?
Okay. Where's the center of the ellipse?
It's at 0, 0, wouldn't it be?
Uh-huh.
Okay. So is this the beginning of it? And then it would be over...
Over what? What is A?
A is it 24?
Uh-huh. It's the distance from the center to the major vertice of that ellipse. In other words, if I finish out that ellipse, by drawing it underground. That's what it looks like. Well, that's the major vertex C. And that's the other major vertex. This is called the minor vertex. That's the minor vertex. And then you have things called the focus. I don't know if you've learned that or not, whether it asks you about it, but let's finish this before we get to the focus, if they do ask you about the focus. What's a squared?
They don't. A squared? Is that 24 squared, or is that the square root of 24?
No, it's a. This is A. From here to here is A. From there to there, that's B. But that is A. So A is 24. This calls for A squared. What is
24 squared is 576.
What's 13 squared?
13 squared. I'm pretty sure there's like a thing. Let me check.
169.
169? Okay.
Now let's simplify this a little bit. We don't need those zeros. Everything else is okay. So it's just x squared over 576 plus y squared over 169 equals 1. There's the equation of that support. If I were to graph it on the xy plane with the center of the ellipse at the origin, which is what I did.
Okay.
And when you're doing these problems, always try to center it about the origin. The reason is that it makes your equation, notice how much simpler our equation is when we don't have a minus h or minus k in these numerators. That's a much simpler equation to deal with, no matter what we're doing.
True.
Now, they have not taught you about the focus yet, because here's what the focus is. There are 2 points on every ellipse. If I draw an ellipse like that, where that's the center, well, there's a focus there and there's a focus there. And the significance of positions, those are key for this ellipse. If you were on, imagine you were on a ice hockey rink in the form of an ellipse. You with me? And you got your hockey stick and a tennis ball. And you aim the tennis ball right there. It always reflects to the other focus, no matter where you hit it. You can aim, if you're standing here, you can aim the tennis ball there. It's going to bounce off and go to that other receiver. You can aim it there and bounce off. So that's a huge property of ellipses, and the focuses are huge. In other words, the main reason we study ellipses is to find those focuses.
Okay.
Not the main reason, but one of the reasons. All the conic sections are important. What are we doing today? A half hour or an hour?
I think we'll call it for now.
Okay. That's fine.
I appreciate it. Thank you.
With me. You're welcome. I will talk to you tomorrow.
See you.
All right, Merrick. Bye-bye.